Hello everyone. Welcome to the first session of physics in your first PUC chapter. Alright. Now in this one, what you will be looking at is what exactly is physics. Alright. That's the basic thing, because till now what you had was you had one subject called as science, isn't it? Now in science you had three divisions: physics, chemistry and biology. Correct? But here once you have entered this particular syllabus, here you have physics as a different subject, chemistry as a different subject, and biology as a different subject. You have three different subjects. Now here we are looking at what is physics. Alright. Now you would have seen lot of natural phenomena. It could be very simple like a lightning or a thunder, or it could be as simple as you're throwing a cricket ball, whatever it might be. Now, all these things are natural phenomena, isn't it? Now, physics helps you in understanding and explaining how that natural phenomena occur and what are those natural phenomena. So, physics in general, you can say it's the study of nature and natural phenomena. Alright? Now that you have understood the basic definition of physics, or you can say it's not a definition, it's more like you have understood the meaning of physics. Now let's look into what history we have in this particular subject or this topic. Alright. Now physics or natural phenomenon, these things that have been studied by a lot of people. Okay. Now this goes back to like BC, I think around 200-300 BC. Now the first person who made a note of these natural phenomena was Aristotle. Okay. Now, Aristotle made a lot of observations. He did a lot of things in astronomy, a lot of things about distance, velocity, displacement, all these concepts. Alright. After that, we had a lot of people. Of course, it's not just one person who has done everything. Okay, it's over centuries, and it's like lot of people did a lot of things. The next renowned person in this field is Copernicus. Now, I think most of you know that Copernicus is the one who at least told the heliocentric theory, that the sun is at the center and not earth. Alright. Now Copernicus was there. Then after Copernicus we have two famous German physicists, Johann Kepler, and another one was from Germany. There were two famous physicists. One was Johann Kepler. Now Kepler did a lot of things in planetary motion, about the orbit of earth, orbit of different planets. Another one was Leibniz. Okay, Leibniz also did a lot of things in fluids. Okay, fluid, like how a liquid will flow in a tube, or fluid dynamics basically. Then we have Galileo. Galileo, all of you would have heard about Galileo, correct? The telescope and Pisa Tower experiment, all those things, isn't it? Then we have Newton, Isaac Newton. Gravity, which all of you know the story. I don't have to tell you that, isn't it? Newton did a lot of things. Then we entered the next age, which is almost we are looking at advancement in physics. Okay. When I say advancement in physics, we are talking about different topics and different subjects of physics. Like it could be light, it could be sound, electricity, magnetism, a lot of things. Alright. Then you have different people will come under a light. For example, we have Thomas Young. Okay, he is also a very famous personality in physics. Then when it comes to electricity, we have Faraday, and also we have Tesla. These two are quite famous in electricity field. Then we enter the next phase of the physics, which is the modern physics. Okay, when we say modern physics, the first person who comes to our mind is Albert Einstein. Albert Einstein, all of you know Albert Einstein, the relativity and everything, isn't it? He is also a very famous person. And along with that, we have another person from India called Bose. Okay, now he is also very famous, actually speaking. Alright, then we have Sir C.V. Raman, the Raman effect. And we have S. Chandrasekhar. He is also very famous. He is a very big physicist. Now, these people, whatever I mentioned right now, they're all in the 19th century period. So this is like early age. because when you compare the age of previous scientists, they are like quite old. Now this is about the history of how who are involved in the development of physics or natural phenomena, whatever you see. Correct? Now that you have understood there are so many people involved, so it's quite obvious that you have a lot of concepts involved in physics. Because not just one person, right? Like there are so many people involved and so many people will give their own concepts. Correct? That's why we have many concepts in physics. Now let's look at very simple topics in physics. When I say simple topics, we are not going to go in detail. It's just a surface overview of what exactly there in physics. The first thing what we have is force. Very simple topic. When you say force, let's look at what are the forces of nature. Because in nature, we have four major types of forces. Alright? The weakest of all of them is gravitational force. I don't have to explain what is gravitational force. All of you know it. Isn't it? Then after that, we have weak nuclear force. Alright? Then you have electromagnetic force. Then you have strong nuclear force. Okay, these are the four forces. Now, if you look at the table, you will understand these four types of forces. Now, gravitational force, when you say gravitational force, now how does this originate? It's like, why? How is it come? Correct? Very simple question. Now, gravitational force is due to mass of the object. It's like more mass an object has, more will be the gravitational pull. Okay? Mass is the reason why we have gravitational force. When it comes to weak nuclear force, what you have is, it is due to radioactivity. Radioactivity is a concept you guys will learn later on. Then you have electromagnetic force. This is due to charges. Positive charge, negative charge and everything. You guys would have learned this in electricity, right? Two charges. This electrostatic force is due to charges. Then you have strong nuclear force. And the strong nuclear force, this is due to the nucleons, which is protons and neutrons, inside the nucleus. Now here, when you look at the comparison, suppose if you take gravitational force as, let's say, 1 Newton. Okay, or take it as 1. If this is 1, then electrostatic force is about 10 to the power of 36 times as strong as gravitational force. 10 power 36. And strong nuclear force is 10 power 38. That's 1 followed by 38 zeros. So as you can imagine here, gravitational force is very less, isn't it? Compared to these two forces. So we have a ratio. It's 1 is to 10 power 36 is to 10 power 38. This is how it goes. How the forces of nature are. These are the four fundamental forces of nature.